Hi, this is Renee Teat, the author of SQL for Data Scientists, and this is Book Walkthrough Session 3, where we'll be covering Chapters 3 and 4 in the book. This is meant to be supplemental to the book, so it's not core instruction, but I'll answer some questions people had after reading these chapters, and also do some exercises from the back of the chapters. I wanted to also remind everyone that you can go to my website, sqlfordatascientist.com, and there's a way to interact with some of the queries there. So you can go to the section called Chapter SQL from any of the menus. This is Chapter 3. You can highlight the query and then scroll down to the bottom, and then there's an interactive SQL editor there where you can paste it, you can modify it, execute it, and see what the results look like. So feel free to play around with the queries there, and just wanted to remind you that's there for your learning. Alright, so I'm looking in Chapter 3 at the back of the chapter, Exercise 1. It says refer to the data in Table 3.1 and write a query that returns all customer purchases of product IDs 4 and 9. Pretty sure I meant 3.2 because that's the one that actually has a query that is looking at the customer purchases table. But let's run this. We get all the records in the customer purchases table. And so you can see there's product ID 1, 2, 3, 4. So we want to filter to just product IDs 4 and 9. So let's start with our where clause, where product ID equals 4. Let's see what that looks like. There's the 4s. And let's see what it looks like when we put a 9. Oh, so there are no customer purchases with a product ID 9. This is not very helpful other than something to learn, that there's nothing returned for that number. So I know when we were scrolling we saw some 2s, so let's do product IDs 4 and 2. Okay, there's the 2s. So if we want product IDs 4 and 2, this is actually the first kind of trick question of the book. So in English we would say product IDs 4 and 2, but when you're talking about SQL, you're talking about every row. There's no row that has more than one product ID. So we don't want to put an and here, product ID 2 and product ID 4, because then we won't get anything returned. So let me just show you that so you believe me. Nothing returned. What we actually want is every row where the product ID is 2 or the product ID is 4. So let's run that. There we go. Now we got the 2s and the 4s and no other numbers. So you can see how you figure things out as you explore the data and go through it. And then also how you translate a sentence, like give me all the product IDs 2 and 4, to know that for each row you want a product ID is 2 or a product ID is 4. All right, let's talk through one more exercise in Chapter 3. So here we have a query in the where clause. So we have where market date is in this whatever's returned by this query. And so the question says, can you think of 2 different ways to change the final query in the chapter so it would return purchases from days when it wasn't raining? So the example in the chapter shows that this is days where it was raining. The market rain flag is 1. So let's first deconstruct this a little bit. So I'll tell you how I would go about answering this question. First, we have to make sure we fully understand this query. So I would probably take out the inner part here and see what that does. And so if I ran that by itself, you could see I get some market dates back, but that's not exactly telling me what's going on there. So I'm going to copy it out and paste it. If you put a semicolon between the queries, you could run a separate query. So I don't want just the market date. I want to see all the columns from these rows that are being returned. So here you see we filtered it to where market rain flag is 1. So that's what's happening here. So I'm getting all the rows from this market date info table. We've got days of the week, months of the year, start and end time of the market date, but I'm just going to return the market date column for the rows where the market rain flag is 1. Okay, so that makes sense to me now. I'm going to remove that, go back up here. So when I say where market date is in this list, we're basically saying market date is in this list of numbers. So these are all the market dates where it was raining. Okay, so we're looking for customer purchases that happened on those market dates. We've got the date, the customer ID, the vendor ID, and the price that they paid for the item. And so if we run that, we now see we're getting date, customer, vendor price. And I have a limit 5 there just to make it return quicker. So we're only getting 5 rows back. And so these are purchases that happen when it was raining. So if I want to flip it to where days when it was not raining, I need this market rain flag to equal 0. So it asked if I could think of 2 different ways to switch this around. So we're actually thinking about the logic going on here. So I'm looking for purchases where the market date is on a day where it's not raining. So one way is to just flip this to 0. I first found dates where it was raining. Now we're going to find dates where it was not raining. Okay. And you can go into that table and check to make sure that July 3rd is a date when it's not raining if you wanted to verify that. Another option is to leave this as 1 and say where the market date is not in this list. So now we're getting all market dates where it's not rain flag is 1, so it's not raining. We got the same results. So you can see logically how you can approach the same problem several different ways. And so here we're showing where the market date is not in a list, where the market date is in a list with a flag equals 1, or where the market date is in a list where the flag equals 0. There's all different ways to approach a problem and get the same SQL result. So that's kind of a common theme you see throughout the book. There's really a lot of ways to approach it. The only difference that people might say in terms of right or wrong, most people won't say a certain approach is wrong. Sometimes certain approaches will slow it down. So if your query is running really slowly or slowing down your whole process, if you have it embedded in some other code, you can always ask the data engineers at your organization or use some query optimization tools to figure out which parts of your query are really slowing it down and see if you can think of a different way to solve the same problem. Here, Stephen Lancaster asks, if the where clause depends on if the values are strings or integers, is there a way to get the data types in SQL, or would you have to get that from the directory or data source? So if your organization has a data dictionary, or if you have access to the actual source code that they use to generate the database or view that you're looking at, you can usually tell but based on the actual table definition or the field definition. But there's actually a way to take a peek in some databases, and I actually did not know whether you could do this in MySQL or not, because I only have really used MySQL for this book. I wanted to use an open source version, so I've used in my career like Microsoft Access, Oracle, Redshift, SQL Server, all different flavors of SQL, but I've not tried this yet for this book. So actually what I did is I Googled it. So a lot of things that you can do in SQL are actually pretty consistent across all those different types of databases I mentioned. So if you learn the basics, you'll know how to do SQL for the other database systems, but you might have to look up some details. So here I Googled MySQL get data type because I wanted to put MySQL in the Google question, since this might be specific to MySQL. So here we find out that in MySQL there's a table called information schema.columns where you can look up information about the columns in your database. So let's take a look at that. So this is actually cool because the answer to this is going to be relevant to our chapter 3 topic of where clauses. So first let's look at what's in this table. So you can see it's a whole catalog. You get all kinds of information about the schema, the table name. I don't even know what some of these tables are. So these are tables that are like built into the MySQL database, column names, and if you look further over here, you have some data types. So I wanted to narrow down what data was returned, both in the number of columns, because this is a lot of columns, and I want to specifically return where the table schema is farmer's market. So I'm not getting generic MySQL tables. I want tables from my farmer's market database, and the table name is product. So what we're going to look at here is some of the data types in the product table. So if we run that, look at that. The product table, we can get information like which fields are the primary keys. We get product ID and product category ID combination are acting as the primary key. Neither of those are nullable because the primary key can't be blank in this case. And those keys are integers, and the rest of the fields are varchars. You can even see the size of the table. So here you've got varchar 45, so it has a maximum length of 45 characters, and this is numeric precision of 10 here on the int 11s. So yes, Stephen, you can return the data types, assuming you have permissions in your database to query this information schema. You can go ahead and just run it and return information about the tables that you're querying. Good question. Okay, so while I was searching Twitter for something that was relevant to the questions for this chapter, I actually came across this tweet exchange from 2018 between Caitlin and I. Caitlin had done a poll to ask people if they prefer putting the commas at the start of the line or the end of the line. Remember earlier in the book, you remember that it really doesn't matter how you format SQL much. You can put tabs, spaces, you could put carried returns in different places. It doesn't care. So people have developed these different approaches, these different formats, and I'll show you why she's asking this. And another thing I responded is that people put 1 equals 1 as the first line after the where clause. So if you've ever seen this, you might have gotten confused because 1 equals 1 will always return true. So why would someone do that? So let me just show you something funny that some developers do. Okay, so when you're playing around with your SQL and you're trying to see what the effect of different changes might be, one thing you can often do is comment something out. And so if I wanted to see what the results would look like here without the column key, I could just put a comment there. The comment formatting is different in different types of SQL, by the way. Here it's in MySQL, in this MySQL workbench, it's 2 dashes and a space. It could be 2 forward slashes. There's a way to do block comments, etc. But anyway, I just commented out the column key line, so you see it's not returned here. But what if I commented out the last one? I'm going to get an error. See if you could tell why. So you see down here, it said error code. You have an error in your SQL syntax. It doesn't tell me why. A lot of the editors don't tell you exactly what the error is. Can you spot it? It turns out that when we comment out the last column name mentioned here, there's a hanging comma at the end. So it's saying, well, there's a comma there, but there's no more fields listed, so that's a problem. So you would have to comment that out as well. Right, so now we could run it and get results. We have removed the column type, but it's kind of annoying to have to put comments there and there. So what some people do, especially if they work with a lot of queries that have long lists, is they'll put the commas at the beginning. So here I'm removing it from the end, and they'll put the commas at the beginning here. I'll put one here as well. So now if I ran them again, we have all the 4 columns again. And now if I comment this out, I just had to comment out that single line because the comma was on the line. So some people do this. You'll see it in some places. That's all they're doing. They're just making it easier to comment and uncomment columns. As far as I know, if there's some other reason people do this, let me know. And then in the where clause, since this chapter is about where clauses, you will also sometimes see people put 1 equals 1 like this. And it's for the same reason. So 1 equals 1 always evaluates to true. So if I run that, I should get the same results. And if I want to comment something out, I can just comment it out like this, and it will still run. Oops, what did I do? Oh, that was weird. It took a while to come back. So apparently that slowed it down slightly, but now it returned a result even though I commented this out. Oh, it's probably because there's a lot more records. If I comment out table schemas, farmers market, it's looking through all of the schemas instead of just farmers market. But note that if I went back to how I originally had it, if I were to just comment this out, it's going to get an error. And it's because it says where and. So the comment means it's skipping this line, so it just sees where and, which is improper syntax. So I would have to comment that out and put this on its own line and run that to get the same result. So it's just avoiding the extra work when commenting things out. You'll see some people put that 1 equals 1. So just some funny things people do while they're editing, but that was what the joke was about with the poll. Some people have strong preferences. I don't have a strong preference either way. It's another example of where it's not really right or wrong. Some people will, be very adamant that you can't do it a certain way, but it's still going to run and give you a result. Okay, so we're going to jump ahead to chapter 4. We're going to look at exercise number 2. And this one says to start with a query from the previous exercise. So, spoiler, this is the answer for exercise number 1. But the second one asks you to add a column where, if any of the products are peppers, to add a column that indicates that's a pepper product. So you might look at these product names and guess that you can find the products that contain the word pepper. That's a good way to approach it. And so first let's do a where clause that will filter our products to those that have the word pepper. So I already pre-wrote it. So here we're using the like type of where clause, like condition, where you put percentages around a word to act as wildcards. So this will return any row that has the word pepper in it with anything before or after the word pepper. It doesn't matter. So let's run that. And there we go. But what if somebody lowercased the word pepper, right? So if we had put lowercase here, we wouldn't get any results because, oh, interesting. In MySQL, it must be case insensitive. This is not true in every version of SQL. Notice that I said I only use MySQL for this book, so this is not true in all the other versions. What you often have to do, and I'm going to do it here just so you see it for, in case you're using another type of SQL, you have to lowercase the product name field and put your like clause in lowercase because they're usually case sensitive. I'm actually really surprised by this. I guess I never tried it out. And so in this case, you are ensuring that you're comparing two strings that are all lowercase. So we're taking the lowercase of the product name and like pepper. So that will return them even if you're using a type of database that has a case sensitive like statement. And even if somebody had typed a lowercase p here for peppers. So let's turn this into a case statement instead of where clause. So here we're just returning the peppers, but the question actually asked us to create a column, which is similar to what we did here, using a case statement to identify the pepper items. So let's create another case statement. So we're looking for cases when, and we could just copy this out from here and remove the where clause. So case when the lowercase product name is like pepper, then we'll put a binary flag. Let's do a 1, otherwise it's 0. And we're going to end that case statement and call that the pepper flag. So now we should get all the products returned because we don't have a where clause there. So it's going to return all the rows and just flag the ones that are peppers. So there we go. Habanero peppers, 1. Whole wheat bread, 0. So there's how we create a pepper flag using a case statement. And this is useful in machine learning. If you have a bunch of different values in a column and you're just trying to flag when you have a particular value. It could be using a like clause. It could be looking for a category. One example, in my line of work, we work with student data. And so there might be like hundreds of different majors. So there could be a student that's a biology major, a history major, whatever. And so if I want to just flag the students that are biology majors, I could look for all the majors that are considered biology majors, make sure they have the word biology in them, because it could be shortened. It could be like BIOL. But assuming that the majors with the word biology in them are, all the majors that are biology majors have the full word biology in them, I could use the same approach to flag biology majors. Probably more sensibly, I would want to pull in the department, and instead of filtering based on a word that I'm hoping is spelled right and not abbreviated, I could just filter to everything in the biology department, which might have slightly different names for majors, but just trying to give a real world type of example for where you might use this. So it just started storming here. I apologize if you can hear any background noise from that. Hopefully my voice is clear. But here I wanted to start with a tweet from Jenna Jordan. If you haven't seen this thread, she actually, since October, has been live tweeting her walkthrough of my book. So if you want to get a preview of all the topics or get a sense of how somebody else responded to the activities in the book, you can check out her thread. And this is one tweet from that thread. She asks, so chapter 4 demonstrated a variety of ways to use case statements, binary flags, continuous values, one-hot encoding, super helpful. These are data wrangling tasks I'd usually use pandas for. So it leaves me with a question, when is SQL preferable? So for those not familiar, pandas is a Python package where you could do a lot of data manipulation and filtering and everything she's talking about here. So this is kind of a loaded question. I would say there are a lot of different potential answers. I use pandas for a lot of these things as well. When I use SQL is when I want to store the exact results for somebody else to use or for me to keep reusing. And maybe I want to hand off the table. For example, if I use this approach we were just using to create an engineered feature table, so a table where it's ready to go into a machine learning algorithm, and I am using, let's say, a random forest algorithm, and somebody else wanted to use the same query and run it through logistic regression. I could hand off my Python and pandas code. Maybe they're using R, maybe they're using something totally different. And so another thing I can do is store my results, which you'll see in the last chapter of the book, store the results of my query as a view or a table, and hand that off to them to try the same thing. So one reason to do SQL is when you're not sure what other kind of downstream technologies you'll be using, and you just want everybody to start with the same data set. Or you want to come back a year later and make sure you're using the same data set without worrying about what version of pandas you're in or anything like that. So that's one example. It's just you want to share the data source, which you might use in a variety of ways. So lots of different potential answers here, but that's one. Just kind of encode your results in SQL. In some cases, it's faster to do certain activities in SQL versus pandas, but I don't get into that in the book. I'm not going to get into that here. So I won't worry about the actual query run speed. Just pointing out one example where you might want to do feature engineering in SQL. So this last question for tonight, I know this video is getting kind of long. Akande asks, I've been reading your book all evening. Thank you. Waiting for the second video. I'm kind of curious, do you have all these queries in your head, or how do you do it when you have to write complex ones? So I will say one thing that's been fascinating about SQL, as opposed to all the other technologies I've used through my career, is it's been consistent from the beginning of my career. SQL has been around forever. So 20 years ago when I was learning SQL in school, I learned these SQL basics, and everything I've done since then is basically a variation on the basics. So whether I've used a different database system, written reports, or done feature engineering for machine learning, it's all variations on a theme. So that's why I included what I did in the book, because I think what I included in the book are the basics that I use most frequently. So if you really get comfortable with what's in the book, then I think you'll have the basis for whatever you need to go out into the world and do. You might have to Google some stuff like I just did to find out about the information schema. There are different functions that you'll use for different types of SQL. So you'll probably be Googling stuff all the time. I still do. But you'll have all the different components that can be combined together. And so you'll have a sense of what SQL can do. And once you know what SQL can do, you can start solving puzzles using it. So it will get ever more complex, and you'll see later in the book we do get some pretty complex queries, but they all, if you break them down, they all use the same components. So that's what I hope to get across with the book, and hopefully that works for you all, learning these basics and then being able to apply them in the real world. Thanks for the question. So that's all I have for today. So that was chapters 3 and 4. Answering questions and doing a walkthrough of some of the exercises. If you have questions for the next 2 chapters, let me look at the date here. So I was a couple weeks late on getting this one out, so I apologize for the delay there. But I like to give at least 2 weeks for people to do the next 2 chapters. So Let's say as of March 19th, get your questions in, and I'll plan to make a video that weekend. We'll see how it goes if I get it on time this time. These aren't really planned videos. I'm just kind of doing them as I go. But I'll plan March 19th and 20th, 2022 to be starting to work on the next video. So get your questions in for chapters 5 and 6 before March 19th, 2022. All right, so that's all for today. Thanks, everybody.